Hello students, today our lesson is vector operators. So in vector operators we first learned about the gradient. Let us consider that we have an operator which is denoted by this sign, and this is known as del or nebula, and this is equal to curly over curly x I plus curly over curly y j cap plus curly over curly z k cap. Here we have taken the x, y and z axis, which are the Cartesian coordinate, and we have these three coordinates in the Cartesian coordinate system. This is x and this is y axis and this is z axis, and this I cap, j cap, k cap are the unit vectors which are in the directions of x, y, z respectively. I cap unit vector in the direction of x axis, j cap unit vector in the direction of y axis, and k cap unit vector in the direction of z axis. And this is curly, which shows the partial derivative with respect to x, partial derivative with respect to y, curly over curly z, curly written as curly, this curly over curly z, that is partial derivative with respect to z. And let us we have a scalar field. A scalar field u such that u is equal to x cube plus y x plus z square, and this is the scalar field, and we are going to apply this operator on the scalar field to get the gradient of this scalar field. So in vector operators, the first vector operator is the gradient. So the gradient of the scalar field is written as del u. This is the gradient of this scalar field. This del was equal to this curly over curly x I cap plus curly over curly y j cap plus curly over curly z k cap of the gradient of this scalar field, that is x cube plus y x plus z square. So this is nothing but the partial derivatives of this scalar field. So we are going to take the partial derivative. So it becomes curly u over curly x I cap plus curly u over curly y j cap plus curly u over curly z k cap. That is partial derivative of the scalar field with respect to x, partial derivative of the scalar field with respect to y, plus partial derivative of the scalar field with respect to z. So the partial derivative of the scalar field. this is equal to curly over curly x into this scalar field, that is this x cube plus y x plus z squared into I cap partial derivative with respect to y of the scalar field, that is x cube plus y x plus z square j cap plus partial derivative of the scalar field with respect to z x cube plus y x plus z square k cap. So this is the partial derivative of this whole scalar field with respect to x. So this becomes 3x square plus y, and this is z axis, this becomes 0 because there is no x axis over here. So this is I cap plus, now partial derivative of this scalar field with respect to y, this becomes 0, this becomes 0, just x j cap plus partial derivative of this scalar field with respect to z, this is 0 and this is 0, 2z k cap. So this clearly shows that this is a vector, because I have already told you that these I cap, j cap, k cap are the unit vectors showing the directions. So whenever there is a direction, there is a vector. Earlier this was a scalar field. A scalar field, there is no vector, just this was a scalar, and this operator, gradient operator, has changed this scalar field into a vector when we have taken the gradient of this scalar field. So the first property of the vector operators is that when we take the gradient of a scalar field, we will always obtain a scalar. Thank you very much.